Good morning. So myself Ritisha and I am from CSPIT C2 presenting a topic on parallel processing. So basically what is parallel processing? Parallel processing is a method to improve computer system performance by executing two or more instructions simultaneously. So basically we can perform more than two instructions at a time over CPU. The goals of parallel processing. One goal is to reduce the time. So basically what is important in this world that we all don't have time. So this is reduce time. Another goal is to solve bigger problems that might not fit in limited memory of a single CPU. Parallelism in a uniprocessor system. It is possible to achieve parallelism with a uniprocessor system. Some examples are instruction pipeline, arithmetic pipeline, and I/O processor. Note that the system performs different operations on the same instructions is not considered parallel. It means that if a system performs different operations on the same instructions, then it is a serial. No, then it's not parallel. Only if the system processes two different instructions simultaneously, it can be considered as parallel. Means at exact 5 o'clock, there are two instructions happening concurrently, then it is known as parallel. Parallelism in a uniprocessor system. A reconfigurable arithmetic pipeline is an example of parallelism in a uniprocessor system. Each stage of a reconfigurable arithmetic pipeline has a multiplexer at its input. The multiplexer may pass input data or the data output from the other stages to the stage inputs. The control unit of the CPU sets the select signals of the multiplexer to control the flow of data, thus configuring the pipeline. So this was all about parallelism in a uniprocessor system. Vector arithmetic unit. Now basically what is vector arithmetic unit? A vector arithmetic unit contains multiple functional units that perform addition, subtraction and other functions. The control unit routes the input values to the different functional units to allow the CPU to execute multiple instructions simultaneously. For example, there are two operations. One is B and C are getting added and the answer is stored in A, and other is E and F are getting subtracted and the result is stored in D. So they both are occurring simultaneously. Then what would CPU do? CPU would route B and C to an adder and E and F to an subtractor for simultaneous execution. So they both can execute at the same time. So they are occurring parallelly. Hence it is an example of parallel processing. Organization of multiprocessor systems. So Flynn was someone who gave its classification, and it was proposed by Michael J. Flynn. It is most commonly accepted taxonomy of computer organization. In this classification, computers are classified whether it processes a single instruction at a time or multiple instructions simultaneously, and whether it operates on one or multiple data sets. So, according to Flynn's classification, there are four types. First is single instruction, single data. That uh, SISD machines execute a single instructions on an individual data using a single processor. Based on traditional von Neumann uniprocessor architecture, the instructions are executed subsequently or serially, one step after the next, until most recently the computers are of SISD types. So here is an example of SISD that every instruction has its own data set and every data set has its own instructions. Another type is SIMD, means single instruction on multiple data. An SIMD machine executes a single instruction on multiple data values simultaneously using many processors. Means that there are many data and the instruction is single, so we require multiple processors for it. Since there is only one instruction, each processor does not have to fetch and decode each instruction. Instead, a single control unit does the fetch and decoding of all the processors. SIMD architectures include array processors. So this is the diagram of SIMD. Third is multiple instruction, multiple data sets. So in MIMD machines are usually referred to as multiprocessors or multicomputers. It may execute multiple instructions simultaneously, contrary to SIMD machines. Each processor must include its own control unit that will assign to processor parts of task or separate task. It has two subclasses, namely shared memory and distributed memory. And the last is multiple instruction single data, but it can be learned theoretically, but it is not practically possible. So this category does not actually exist. This category was included in taxonomy for the sake of completeness, so that we can say that there are four possible combinations and permutations of it, but this category in real life does not exist. So this was all about my presentation. Thank you.